A black hole is the closest thing the universe has to forever. It is the last word in destruction, a place where matter, light, time itself, and maybe even information fall in and never come back out. So here is a question that sounds almost absurd. Can a black hole itself die? Can the thing that ends everything else come to an end? The answer, worked out in the 1970s and still echoing through physics today, is yes. And it is one of the strangest, loneliest, and most beautiful stories science has ever told. Let me start with what we actually know, because for most of history we thought the answer was no. A black hole, by definition, is a one-way door. Things go in, nothing comes out, not even light. So it should last forever, only ever growing as it swallows more. That was the picture until 1974, when a young physicist named Stephen Hawking did a calculation that stunned everyone, including himself. He found that black holes are not perfectly black after all. They glow. Very faintly, but they glow. Here is why: empty space is not truly empty. Down at the quantum level it churns, constantly, with pairs of particles flickering into existence and annihilating again, borrowing a little energy and paying it back almost instantly. Now imagine one of these pairs popping into being right at the edge of a black hole, right at the event horizon. Sometimes one of the two falls in while the other escapes. The one that escapes carries away a tiny scrap of energy. And because energy is mass, the black hole has to pay for it by getting very slightly lighter. Particle by particle, over time, the black hole leaks itself away into the universe as a faint hiss of radiation. We call it Hawking radiation. It means a black hole is not a sealed tomb, it is a slow leak. So black holes evaporate, they have a lifespan, they die. But here is the first staggering thing. The timescale is almost beyond meaning. For a black hole left behind by a dying star, a few times the mass of our sun, the time it would take to fully evaporate is around 10 to the 67 years. That is a 1 followed by 67 zeros. For a supermassive black hole, the billion sun monsters at the centers of galaxies, it is more like 10 to the 100th year, a number so large it has a name, a googol. To put that in perspective, the universe right now is about 14 billion years old. These black holes will outlive the present universe not by a little, but by a margin so vast that 14 billion years rounds down to nothing against it. And there is a cruel twist in how they go. You would think a thing that takes a googol years to die would fade out gently, like an ember. It does the opposite. As a black hole loses mass, it gets hotter, and the hotter it gets, the faster it radiates. The evaporation feeds on itself. So for almost its entire life, a black hole barely glows, colder than the space around it. But at the very end, in its final fraction of a second, the last of its mass converts into a runaway burst of radiation, a flash equivalent to millions of nuclear bombs going off at once. A black hole does not whisper out. It dies in a scream of light. Slowly, 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 then all at once. Now sit with what that means on the largest possible scale, because this is where it gets quietly devastating. Walk into the deep future. The stars go first. New stars stop forming, then the existing ones burn out, one by one, until the last red dwarf flickers and dies, maybe 100 trillion years from now. After that, the universe goes dark, cold, empty. Galaxies drift apart and dissolve. Matter itself may slowly decay. And in all that endless darkness, what is left? Black holes. They become the last great structures in existence, the final lords of a dead cosmos, sitting in the black for unimaginable spans of time. And then, one by one, even they begin to evaporate. The last black hole in the universe will reach the end of its googolier life, shrink, heat, and detonate in a final flash, and that flash will be the last event the universe ever has. The last light. After it fades, there is nothing left that can happen ever again. The death of the final black hole is, as far as we can tell, the closest thing there is to the true end of everything. So that is the known part, and it is bleak enough. Now here is where it gets speculative, and I will be honest about which parts are guesses, because the very end of a black hole sits right at the edge of what physics can describe. The question is simple. When a black hole finishes evaporating, what is actually left? There are three families of answers. The first and the standard one is that it simply vanishes. The black hole radiates away its last scrap of mass and is gone, leaving behind only the fading radiation, and then not even that. A complete erasure. The thing that ate stars ends as nothing at all. The second possibility is that evaporation does not quite finish. Some ideas from quantum gravity suggest that when a black hole shrinks down to the smallest possible scale, the Planck scale, the process stalls, and it leaves behind a tiny, frozen nugget, a remnant, holding a sliver of mass and unable to decay any further. If that is right, the universe ends not empty, but littered with countless cold, eternal remnants, the fossilized hearts of dead black holes. And the third possibility is the wildest. Maybe the center of a black hole is not an endpoint but a turning point. Maybe, in a full theory of quantum gravity, the collapse bounces, and what looks like a black hole slowly transforms into its opposite, a white hole, an object that does the reverse, spilling back out everything that ever fell in. In that picture, a black hole does not die. It eventually gives birth, releasing everything it swallowed across a span of time, so long it might as well be forever. Which brings us to the catch, the thing that ties all of this into a knot. Remember that the black hole evaporated into Hawking radiation that looks completely random, featureless, carrying no detail about anything it ate. But quantum mechanics has an iron rule. Information is never destroyed. The universe always, in principle, remembers what fell in. So if a black hole swallows a library, a star, a person, then radiates away into random noise and vanishes, where did all that information go? It cannot be inside, because the inside is gone. It cannot be in the radiation, Hawking first argued, because the radiation is random. So it is just erased, and that is forbidden. This is the black hole information paradox, and it has divided brilliant minds for 50 years. But in just the last few years, theorists have found the first real cracks of light. New calculations, building on the idea that a black hole is somehow a hologram of its own surface, suggest that the information does come back out after all, woven subtly into that escaping radiation in a pattern too intricate for Hawking to have seen. If they are right, then a black hole's death is not an erasure at all. Everything that ever fell in, every star, every secret, is smeared into the faint final whisper of light it gives off as it dies. Nothing is truly lost. It is just scattered into a glow that almost no one will ever read. So do black holes die? Yes. Slowly, for a googol years, and then all at once in a final scream of light. And what is left behind is the purest cosmic maybe I know. Maybe nothing. Maybe a frozen, eternal remnant. Maybe a white hole rebirth, returning everything it took. Maybe a ghost of every star it ever ate, encoded in its dying glow. The science is real. The radiation, the timescales, the final flash. The rest is the edge of what we can know, the last unanswered question about the last objects in a dying universe. And somewhere out there, a googol years from now, the last black hole will flare and fade and carry the final answer with it into the dark.